An analytic function of a complex variable z is equal to x plus iota y is expressed as f as a function of z is equal to u as a function of x and y plus iota v, which is also a function of x and y, where iota is equal to square root of -1. If u is equal to x square minus y square, then the expression for v in terms of x and y and a general constant c would be, since it's given that the function is analytic, that means it will satisfy the CR condition, the Cauchy-Riemann's condition. Okay, so let's write here, since the function f of z is analytic, it's an analytic function, therefore it will satisfy CR condition. And we know, according to the CR condition, the partial derivative of u with respect to x is equal to partial derivative of v with respect to y, and partial derivative of u with respect to y is equal to negative of partial derivative of v with respect to x. Also, f, as it is already defined here in the problem, f of z is equal to u plus iota v, and z is equal to x plus iota y. Okay, so this is the CR condition that should be satisfied if the function f of z is analytic. Okay, now in the problem we are given the value of u, so u is equal to, u as a function of x and y, of course, this is equal to x square minus y square. Okay, now if we use the first CR condition, that is this one, the partial derivative, let's find out, partial derivative of u with respect to x will be equal to 2x, and that we know from here that this is also equal to dou v by dou y. Okay, now let's consider just these two. So let's write here 2x into dy is equal to dou v by dou y into dy. We can write like this. Now if we integrate it both sides, we'll get 2xy plus a constant, let's say k, is equal to, this will be dv. Okay, so let this be equation number 1, and this constant k will be a function of x. Okay, because v is a function of x and y, and here we are integrating with respect to y only, so k must be the function of x. So let's write k should be some g of x. Alright, now let's use the second CR condition. So according to the second CR condition, we know dou u by dou y should be equal to negative of dou v by dou x. So dou u by dou y will be equal to negative 2y, and this is also equal to negative dou v by dou x. So we can also write this as 2y into dx is equal to dou v by dou x into dx. Now if we integrate it both sides with respect to x, what we'll get? We'll get here 2xy plus some constant, and this constant must be a function of y, because here we are integrating with respect to x, and v is a function of both x and y. So this will be, let's say, some h of y is equal to v. Okay, let this be equation number 2. Now if we compare equation number 1 and 2, comparing equation 1 and 2, we can write v is equal to 2xy plus some constant c, let's say c, right? Because here if we compare this equation number 1 with 2, so g of x, there is no term which is only function of x here, and in the first equation there is no term which is a function of y. Okay, so the summation of h of y and g of x must be a constant, and that constant here is c. All right, so this must be the value of v. So the correct option would be option C, 2xy plus c. For more information, you can refer to the NPTEL course, lecture number 1, Analytic Functions of a Complex Variable on Selected Topics in Mathematical Physics by Professor V. Balakrishnan of the Department of Physics at IIT Madras.